students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 12th physics, electric current electricity, chapter 3, ncert solution, part 2. Our mission is to provide free classes on YouTube for all the students of class 6 to class 12 and special classes for the students preparing for IIT, JEE, NEET, NDA and other competitive examinations. Before we begin, we have a small request. Please subscribe, like, and share our channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin the lesson. So our next sum is 3.9. Determine the current in each branch of the network shown in figure 3.30. Let us see the solution. Current flowing through various branches of the circuit is represented by the given figure. So in this figure. So let us consider that current I1 is flowing from EA, and this current again divided, I1 is divided into I2, and which is moving in the branch AB, and I3 which is moving in the branch AD, this side. So that means if we at any time if we add, I1 will be equal to I2 plus I3. Now this I2 again breaks up, some portion of I2 moves here at BD, that is I4. So rest of the current, that means rest of the current means I2 minus I4 moves in the branch BC. Again, if we see what is happening in point D, I3 comes from here, from this side, from AD, from A, and meets with I4. So at any point, at point D, the total sum of the current is I3 plus I4, which moves to the direction or to the arm DC. So I3 plus I4 moves to the arm DC. Why? Because I3 is coming from AD and I4 is coming from BD. So they meet together and the sum is I3 plus I4, which moves towards DC. At point C, what is happening? I2 minus I4 is coming from BC. I3 and plus I4 is coming from DC, and here it is the algebraic sum of I2 minus I4, I3 plus I4. Then if we cancel it, so it is I2 minus I4. So at point C, I2 minus I4, which is flowing from BC, this current, and I3 plus I4, which is flowing in the arm DC meets and I4 gets cancelled. So here the total current is I2 plus I3, which moves in this way. So I2 plus I3 is, again we can write this is equal to I1, which is given here, which again flows to the battery. So this is the description. Now let us see, for a closed circuit ABDA, potential is 0. We know that in a closed circuit the potential is 0. So we can write IR, that means resistance into current. So 10 into I2 plus 5 into I4 minus 5I3 is equal to 0. So why we have taken it? Let us see the image again. So we know V is equal to IR. So for branch AB, what will be the V? V will be multiplication of resistance and current. What is resistance? 10 ohm. What is current? I2. So potential potential will be potential will be 10 into I2. Now now what is, so 10 I2 is the potential difference for A to B. Now what is the value of, so what is the potential between B and D? B and D. So potential difference is V is equal to IR. So here the potential is I4 into 5 or 5 into I4. Fine. Next, what is the potential difference between AD? It is 5 into I3. But the direction of this current is opposite to that of the current flowing in AB or BD. Therefore, it will have a negative sign. So we have put minus 5I3 here, which is equal to 0. Therefore, if we take common 5, then the equation becomes 2I2 plus 4I4 minus I3 is equal to 0. Now we can write I3 is equal to 2I2 plus I4. This is equation 1. Similarly, in the closed circuit BCDB, potential is 0, that is 5I2 minus I4 minus 10I3 minus 10I4 minus 5I4 is equal to 0. Now on calculation we get 5I2 minus 10I3 minus 20I4 is equal to 0. That is I2 is equal to 2I3 plus 4I4. This is equation number 2. Similarly, for the circuit ABCFEA, potential is 0, that is minus 10 plus 10I1 plus 10I2 minus plus 5I2 minus I4 is equal to 0. Therefore, on solving, we get 10 is equal to 15I2 plus 10I1 minus 5I4. On solving, we get 10I2 plus 2I1 minus I4 is equal to 2. This is equation 3. Equating from equation 1 2 we obtain I3 is equal to 2I3 plus 4I4 bracket close plus I4. Now I3 is equal to, upon solving we get 4I3 plus 8i4 plus i4, that is minus 3i4 is equal to 9i4, minus 3i4 plus i4. Upon solving, we get uh, upon solving we get minus 3i4 is equal to plus i4, that is equation number 4. Putting equation 4 in equation 1, we get i3 is equal to 2i2 plus i4, 4i4 is equal to 2i2, and I2 is equal to 2I4, that is equation 5. It is evident from the given figure that I1 is equal to I2 plus I3 or I3 plus I2, same thing. Putting equation 6 in equation 1, we obtained 3I2 plus 3 I3 plus I2 minus I4 is equal to 2. 5I2 plus I 2i3 minus i4 is equal to 2. This is equation number 7. Putting equation 4, 5 in equation 7, we get or we obtain 5 minus 2i4 plus 2 bracket minus 3i4 minus i4 is equal to 2. Upon solving, minus 10i4 minus 6i4 minus i4 is equal to 2. That is 17i4 is equal to minus 2. I4 is equal to minus 2 upon 17a. Equation 4 reduced to Equation 4 reduced to I3 is equal to minus 3 I4, that is minus 3 2 upon 17, that is 6 upon 17 ampere. I2 is equal to minus 2 I4, that is minus 2 bracket minus 2 upon 17, that is 4 upon 17 ampere. I2 minus I4, that is 14 upon 17, that is minus 2 upon 17, that is 6 upon 17 ampere. Now I3 plus I4 is equal to 6 upon 17 plus minus 2 upon 17, which gives 4 upon 17 ampere. I1 is equal to I3 plus I2, that is 6 upon 17 plus 4 upon 17 is equal to 10 upon 17 ampere. Therefore, the current in branch AB is equal to 4 upon 17 ampere. In the branch BC is equal to 6 upon 17 ampere. In the branch CD is equal to minus 4 upon 17 ampere. In the branch AD is equal to 6 upon 17 ampere. In the branch BD is equal to minus 2 upon 17 ampere. Total current is equal to 4 upon 17, 6 upon 17 plus minus 4 upon 17 plus minus 6 upon 17 plus 6 upon 17 plus minus 2 upon 17. Answer is 10 upon 17 ampere. Now let us see problem number 3.10 part A. In a meter bridge, the balance point is found to be at 39.5 centimeter from the end A, which when the resistor Y is of 12.5 ohm, determine the resistance of X. Y are the connection between resistors in a whetstone or meter bridge made of thick copper strip. B. Determine the balance point of the bridge above if X and Y are interchanged. C. What happens if the galvanometer and the cell are interchanged at the balance point of the bridge? Would the galvanometer show any current? So let us see the solution. A meter bridge with register X and Y is represented in the given figure. So therefore we can write balance point from A L1 is equal to 39.5 centimeter. Resistance of the resistor Y is equal to 12.5 ohm. Conditions for the balance is given as X upon Y 100 minus L1 upon L1. X is equal to 100 minus 39.5 upon 39.5 into 12.5, that is 8.2 ohm. Therefore, the resistor X is 8.2 ohm. The connection between the resistors in a whetstone or meter bridge is made of thick copper strip to minimize the resistance, which is not taken into consideration in the meter bridge formula. B. If X and Y are interchanged, then L1 and 100 minus L1 get interchanged. The balance point of the bridge will be 100 minus L1 from A. So 100 minus L1, that is 100 minus 39.5, that is 60.5 centimeter from A. When the galvanometer and the cell are interchanged at the balance point of the bridge, the galvanometer will show no deflection, hence no current would flow through the galvanometer. And this is the end of today's class. In the next class, we'll start with the new question. Please subscribe, like, and share our channel among your friends and relatives. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded. Thank you very much for supporting us and watching Experience Tutor YouTube channel.